All right, I'm going to go ahead and go over the solving systems practice quiz with you guys here so that you can check your answers when you're studying and make sure that you are set for tomorrow. I'm actually going to start on the back side of the page first just to save the word problems for the end because those take a little bit longer to go through. Okay, so for this, for number 5 through 9, basically you're solving the solution, the systems, using a method that you think seems appropriate. So I'm only going to let you use the graphing method once, and then you're going to have to decide between substitution and elimination. Okay, so just looking at these problems here, I already pulled out that I'm going to use graph problem 6 and graph that because they're already in the y equals mx plus b form. I always like to figure out which ones I'm doing before I do them, so I'm just going to write a note out here. I'm going to graph this one. Okay. As for the other ones, you just have to use each method once, so I think we should be fine to decide as we go for those. So for number 5, I'm looking at this and I notice that these two y's have opposite coefficients. I have a negative y and a positive y. This is going to lend itself well to do the elimination method. Okay, because when I add these equations together, those y's will cancel each other out. So I'm going to add these two, and I'm going to use elimination method. They're already opposite coefficients here, so I can cancel those y's out, which is nice. All right, so 2x plus a negative x is going to give me a positive x, positive 1x. This negative y and this positive y are going to cancel each other out. And a negative 10 plus 4 is a negative 6. So I found my x. To solve for my y, I'm going to go ahead and plug it back into one of my equations. I'm just going to plug it into my second equation. So I have a negative 6 plus y equals 4. This is a 6 plus y equals 4. Subtract 6 from both sides. And I get y equals negative 6. Or sorry, negative 2. I wrote 2 and I said 6. Okay, so my x solution would be negative 6 and my y would be negative 2. Moving along, for number 6, I'm going to graph it on this graph here. So remember, when you have graphs, they're in y equals mx plus b form. Since these are in that form, it's easy to graph. Our b tells us our y-intercept. So where is it crossing through the y-axis? For this first equation here, my b is 3. So on my y-intercept, on my y-axis, I'm going to go to 3, and I'm going to put my first point, and then I'm going to look at the slope. So in this first equation, my slope is just 1. You could think of that as 1 over 1. And the numerator represents your rise, the denominator represents your run. So starting at my y-intercept of 3, I'm going to rise 1 and run 1. So now I'm at 1, 4. Again, rise 1, run 1. And then I would connect these dots. Ooh, I need a ruler. You guys should hopefully have a straighter line than me, since I am using freehand here, but essentially this line is going to go down like that. Okay? So there's my first line. My second line, there is no b. Whenever you don't have a b, that means it's going through the graph at 0, 0. So my y-intercept is 0. In this equation, my slope is negative 2, which I can think about as a negative 2 over 1. So my rise would be negative 2, meaning I'm going down 2 over 1. Down 2 over 1. And then in reverse, if you want to go up to the left, I can go up 2 and then to the left 1 to continue on. And if I connect these points, you'll notice that they are going to cross at the point negative 1, 2. Okay, and then if you want to ever check your graphing, you can plug these values back into one of your equations and see if it works. So I'm going to do that with you here. I'm going to plug it into the first equation. So I have 2 equals -1 plus 3. I get 2 equals 2, so I know that my answer checks out. All right, number 7. Number 7, since I see that I have a y already isolated on one of my equations, I'm going to go ahead and use the substitution method for this one. Remember, with substitution, you're substituting these values in for the y on your first equation. So for this problem, I would have 4x minus 6 equals 2, and instead of y, I'm going to substitute 2x minus 3, since y is equal to 2x minus 3. When I simplify this, I get 4x minus 6 equals 4x minus 6. These are the same, so this problem actually has infinitely many solutions. Okay? Because they're the same, meaning that any value that I put in for x or y is going to give me the same answer. So these lines are essentially the same line. They're right on top of each other. Number 8. I'm going to go ahead and use substitution method as well for this problem. So I am going to, since I see this x all by itself, I see one of my variables isolated already, I'm going to go ahead and take advantage by plugging in this into my x on my first equation. So I would have 4 times y minus 4 plus y equals -1. I just took the x and substituted it with y minus 4. I'm going to use the distributive property here, and I get 4y minus 16 plus y equals -1. I'm going to combine like terms here, so I would have 5y minus 16 equals -1. Add 16 to both sides, and I get 5y equals 15. Divide by 5, divide by 5, y equals 3. Then I'm going to take this 3 for y, and I'm going to plug it into one of my equations to solve for x. So I'm going to plug it into my second equation there. 3 minus 4 equals x. 3 minus 4 is -1, so x equals -1. My solution is -1, 3. And then the last one on this page, we have 2x minus 3y equals -14, and 6x plus 6y equals 18. For this one, there's not really one that lends itself more than another, but I think that the best method to use here would be elimination. The reason why is because there are common multiples between these x coefficients and these y coefficients that it would be easy just to multiply one of them by a number. So I noticed that with my y's, I have a negative and a positive coefficient. So I'm just going to take this entire equation here and multiply it by 2. When I do that, I know it's going to give me a -6y, which will cancel out this positive 6y. So when I do that, I get 4x minus 3y equal 6y equals -28. And then I'm going to keep the second equation the same. 6x plus 6y equals 18. This is also called the addition method because you're essentially adding these equations together. 4x plus 6x is 10x. These cancel out. And I get -28 plus 18, which is a -10. Divide both sides by 10. X equals -1. Then you're going to go plug it into one of your equations. So I'm just going to plug it into the second equation. 6 times -1 plus 6y equals 18. -6 plus 6y equals 18. Add 6 to both sides. I get 6y equals 24. Divide by 6. Divide by 6. Y equals So my solution for this one would be -1, comma